Hi, welcome to educator.com. Today we're going to be talking about Stemplots. We're going to talk about Stemplots because they're another kind of visualization. Well, what sets them apart from other kinds of ways that you could visualize a distribution? What do they look like, and how did we construct one? I should say up front that Stemplots aren't frequently used, but they are sometimes used in tests and in classes, and they're frequently mentioned in textbooks, which is why I'm covering it in a lesson. But if you're working with very, very large data sets, Stemplots won't be very useful to you. So if you're actually trying to work with data, you might want to just skip this lesson. All right, so what sets Stemplots apart? Well, let's think about this. When we look at data sets, those rows and rows and rows of data, they include the exact values, but it doesn't show us the distribution visually. I mean, it's almost impossible to actually see the distribution. The nice thing about dot plots and histograms is that it shows you the distribution visually. You could see the shape. You could sort of see the center and the spread, how spread out it is. But unfortunately, they don't always show the exact values. Sometimes dot plots do, but only if you have very, very small number, small range. Stemplots are a way of grouping values, yet it includes the exact values. So it's sort of nice. It's like between the dot plot and the histogram. You could group them together, bin them together, but you could still see the exact values. And it shows you the distributions visually. So what do Stemplots actually look like? Well, here's our first example. They're also called stem and leaf plots. The stems are really the tens digit, and the leaves are actually the ones digit of your data, right? So let's take this class. Let's say it's a physics class, and here are the test grades for all these people. And I've put it already in order from the least to the greatest. So a couple of people are really doing poorly in this class, actually like more than half. But these people are doing sort of well, but they seem to be a minority. Let's look at it on a stem plot. On a stem plot, we put the tens in one column, right? So the tens that we have are 2, 3, 4, 5, 6, 7, 8, and 9. And here are the ones numbers. So what I've taken, I'll put it in a different color, is I've taken this number and I've split it apart into 2 and 0. Now I look at the next set. There are 3 people who scored in the 30s. Oh, but I'm missing one of them. And so it should be a 0, a 7, and also an 8, right? Now let's look at all those people who scored in the 40s, which looks like this is the majority. So I would put the 0, the 0, the 2, the 2, the 5, the 5, the 8, and the 8, right? And then let's look at those who scored in the 50s. There's one person who scored 50 and one person who scored at 52. And then 67, so I put the 6 here and the 7 here. For the 70s, there's 3 people, so I put the 2, the 7, and the 8, the ones places. And for the 80s, there's 2 people, the 0 and the 8. And for the 90s, there's just one person who got a 97. Now, when you look at this stem plot, to read each of these values, you can't read this as 3,078. You have to read it as a 30, a 70, a 30, a 37, and a 38, right? And this is a 40, a 40, a 42, 42, 45, 45, 48, 48, right? And when you look over here, you could see a distribution. And if you imagine tilting this over on the side, you would see that this is a right skewed. Distribution. All right, so that's what the stem and leaf plot looks like. The other thing you could do is you could create back-to-back stem plots. You could use the same stem, but have leaves coming off either side of it. And this way you could compare two distributions at once. So let's say in the same physics class, someone was interested in whether it helps to have had calculus before, because calculus is really the math that underlies physics. So we've put all the people who have not taken calculus before, the no's, and put them up here. And we've put all the people who have taken calculus before down here. Now let's put it on a stem plot. So the stems are going to be the same, 2, 3, 4, 5, 6, 7, 8, and 9. But let's start with the no calculus distribution. Here we have somebody who scored a 30, so nobody who scored in the 20s. So here's a 30. Here's two people who've scored in their 40s. Here's one person who scored in the 50s, and then this very high performer has also not taken calculus before. Rather surprising. All right, now let's look at those people who have taken calculus before. Here's one person in their 20s, right there. Two people who scored in their 30s, 37 and 38. Lots of people who've scored in the 40s, 40, 40, 42, 45, 45, and 48. One person who scored in the 50s, 52. One person who scored in the 60s. Three people who've scored in the 70s, 72, 77, 78. And two people who scored in their 80s, 80 and 88, right? And now let's look at the distribution. Here, the distribution seems to be something like this. And here, the distribution roughly looks similar. They're both right-skewed distributions. Remember, right skew means that the tail is with the high values. Right? So that's how we know that they're right skewed, even though right now it seems like they're sort of down skewed or south skewed.